Guys, we're talking about 10.7 today, and that includes the topic of writing and graphing equations of circles. So to start off, I've written out a problem for us. And this is taking some information about a circle. We don't see it, right? It's just described to us, and we're going to take this information and then write out an equation that represents the equation form of a graph of a circle. Okay, so we're going to take the two things that we need and write the standard equation of a circle. So to write the standard equation, right, and I've got that in purple there, to write the standard equation of a circle, all you need is the center and the radius. That's it. All you need is the center and the radius. Now, when we look at the center of a circle, we represent this with H and K. We write the center of a circle as HK. And you guys will understand this whenever we actually write out what the standard equation of a circle is supposed to look like, right? So we use the variables H and K only when referring to the center of a circle. And then we use the radius. The radius is always going to be referred to as R, which makes sense, right? So we've got our center, which is at HK, or in this case 0, -9, and the radius, which is R, in this case, is 4. Okay, so to do this, we're going to need to know what the standard equation of a circle is. So if I had a circle that was centered, let's go centered at the origin. Okay, so our center is at 0, 0, and we've got just some circle doing something like this, right? I could get some point on that circle and say, well, this point is X units to the right and Y units up from the center, right? This is X units to the right and Y units up from the center. I could find any point, right, along the edge of this circle, and it could be represented as a coordinate, as an XY coordinate. Well, what is this line right here represented by? What is that? Well, that is our radius, right? That's the radius of this circle. And if we look at what we've just created, we've got ourselves a right triangle, right? And I could find the radius of this circle. I could find the radius of this circle by using the Pythagorean theorem. I could say, well, x squared plus y squared is equal to r squared. This is the equation of a circle. X squared plus y squared equals r squared. Now, the only thing is that this is only going to work when the center of our circle is at 0, 0, right? It only works when the center is at 0, 0. We can find the radius of the circle based on any coordinate that is on this circle. Or we could find, any coordinate based on the radius and some x input or some y input, right? We could find any coordinate or any radius that matches this circle utilizing this information right here. Now, when we have a different center, right? When we've moved this center, like this one right here, where I've got a center at 0, -9. Well, what I need to do is I need to think about, well, how does that change my x? How does that change my y? Well, our x hasn't changed at all in this case, right? Our x has not changed at all because it has not moved, right? We have moved nowhere in the x direction, but we have moved in the y direction. So this leads us to the standard equation. This leads us to the standard equation of a circle. The standard equation of a circle. And this reads, we're going to take x and we subtract that h value that represents the x value of our center. And we add y minus k, which represents that y value of our center. Square that, and that's going to be equal to our radius squared. Notice how similar these two look. The only difference is that now we've got this h and we've got this k inside our parentheses, right? Inside these squared parentheses. And these are just saying, hey, if I need to get x back to 0, if I want to get that back to the origin, well, I need to subtract whatever movement I have made, whether that be positively or negatively. If I want to get y back to the origin, well, then I need to subtract whatever k value I've used to move the center of this circle, right? So now if I were to graph this circle, and let's draw ourselves a nice little graph here. Let's draw a nice little graph. If I were to plot this circle, and it can be anywhere, right? This is just an arbitrary circle with center of hk. All right, let's put it over here. This has a center at hk. This coordinate is hk. Right? I've moved h units to the right, and I've moved k units up to find the center, right? And then I've got some radius, r. Okay, so if we want to plot anything using a standard equation, all we have to do is notice, well, where is my center and what is my radius? Okay, so let's go back to this problem up here. Right, the standard equation of a circle is center 0, -9, and a radius of 4. Let's go with a fancy color here. Let's go with this little guy. So what I'm going to do is I'm going to write this as follows. Oops, not plus. It's going to be equal to whatever our radius is squared. So inside these parentheses, we're going to put x minus h. Well, what is our h in this case? Well, our h is 0. So I've got x minus 0 plus y minus, well, what is our k value? It's -9. Right, notice we've got y minus k. K is negative, so I'm subtracting a negative. And the radius of my circle is 4, so I'm just going to throw 4 squared in there. Now, I don't want to have to leave the equation of a circle looking like this. X minus 0 squared plus y minus -9 squared is equal to 4 squared, right? It's not pretty. It's not totally simplified. So what we're going to do is let's go ahead and just, I'm sorry for this being a little all over the place, but let's rewrite this as it was meant to be, as the good Lord would have liked us to write this out. Okay, so let's rewrite this as x. Well, what is x minus 0 squared? Well, that's just x squared. What is y minus -9? Well, that's going to be y plus 9 squared. And 4 squared is 16. So this right here is the equation of a circle that has a center at 0, -9, with a radius of 4, right? So this is whenever we are given the different, different aspects of a circle, right? They're given to us as a center and a radius. We can come up with the equation of it. Now, what if we are given the equation of a circle and we want to then graph said circle, right? So what if we want to graph x minus 4 squared plus y plus 2 squared equal to 36. What if we want to graph this equation, right? I've got x minus 4 squared plus y plus 2 squared is equal to 36. Well, what I would recommend you guys doing is going ahead and say, well, where's the center of this circle? Where is the center? What is the radius? When you have these two pieces of information, the graph is just going to come so naturally. Okay, so the center, we know, is always going to be at H and K, right? H and K. Well, what is H? In this case, H is 4. Oops. H is 4. Now, some of you might be saying, wait, but Mr. Peters, there's a negative in front of that 4. But remember what we've done here. We've said that we always subtract H from X. We always subtract K from Y. So in this case, we are subtracting H, and H is just 4. And then for our Y value, we are doing Y minus K. So what is K in this case? Yeah, anybody? Hands? Okay, yeah, Levi, what do you think? Oh yeah, it's negative. Yeah, it's got to be -2, right? We are subtracting K. So this is Y minus K. K in this case has to be -2. We've got the center of our circle. It's right there at 4, -2. And that's easy enough to plot. We'll do it in a second. Well, what's our radius? Well, if I've got 36 over here, and I know that the standard equation of a circle leaves me with r squared, all I need to do is take the square root of 36. R is going to be the square root of 36, or equal to 6. So I've got my center, I've got my radius. Let's graph this guy. Okay, let's draw in our little graph here. And let's find the center of our circle. The center of our circle is at 4. So 1, 2, 3, 4, -2. 1, 2. Right there. There's the center of our circle. Now from here, what we need to do is say, well, how can I plot the radius from this? What I recommend you doing is just going up, down, left, and right. We need to create 4 points. We're going to go up 6. 1, 2. See, 1, 2, 3, 4, 5. We're going to go 1, 2, 3, 4, 5, 6. We're going to go to the right 6. We're going to go down 6. And then we'll go to the left 6. 1, 2, 3, 4, 5, 6. From here, and I know this isn't perfectly drawn to scale, but what we can do from here is just kind of create these quadrants, these arc quadrants, and connect them with a little bit of a swooping motion. Ooh, that's ugly. Ugly. Little bit of a swooping motion to draw out our circle. And this is a hideous circle. I know y'all's will be so much better. I'm no artist. Cameron, Caroline, I expect y'all's to be beautiful. Mine is hideous. But I can see this. Look, this has a distance of 6. I've got a distance of 6. Distance of 6. Anywhere that I draw a radius on this, I'm going to have a distance of 6. It doesn't look like it on my hideous drawing, but any coordinate on here, any x, y coordinate on the circle will satisfy this equation. All right, so let's say I'm gonna do one of the homework problems, and what we're gonna do with this homework problem is just ask ourselves, hey, is this point on the circle or not? Right? Is it on the circle? Is it inside the circle? Or is it outside the circle? Okay, so the equation that I'm going to be looking at is x plus 2 squared plus y plus 6 squared is equal to 25. And I want to know if the coordinate point, is the coordinate point, and I said this was a homework problem. It's actually not a homework problem. I apologize. Is the coordinate point -3, 6? Is this point, -3, 6, on, in, or outside the circle? And what I mean by this is, hey, when I draw this circle and I plot this point, is it going to be here? Is it going to be here? Or is it going to be here, right? Is it going to be on, in, or outside the circle? One way that you could do this is just plot it, right? I could look at this circle and say, okay, well, I've got a center at -2, -6. Let's do that. I've got a radius of 5. We can set up the drawing of that circle. Then we can plot the point. But the only thing is when we draw a circle, it's not going to be perfect, right? We're going to have human error. So what I recommend you guys doing is taking this coordinate. Now remember, this coordinate right here, we want to know if it's on, in, or outside the circle. So it does not reference the center. Does not reference the center. What we're going to do is we're going to plug that in for x and y. We are going to plug this coordinate in for x and y. Let's go blue. All right, so what I'm going to do is I'm going to take -3, and I'm going to plug that in for x. I'm going to take 6. And I'm going to plug that in for y. And I'm going to set this equal to 25, right? I'm just taking all my values, plugging them in, and seeing what happens. Well, let's see. What's -3 plus 2? Well, -3 plus 2, that's -1 squared is 1. What is 6 plus 6? Well, 6 plus 6 is 12, and 12 squared, 12 times 12 is 144. Is that equal to 25? No. This is actually 145 is greater than 25, right? This is greater than 25. What does that tell us? Well, this tells us since it is larger, this coordinate is outside the circle. This is outside the circle. So I know this is outside. Oops, I know this is outside because the value that I got when I plugged this in is greater than my radius. So what we know is if the value is larger, if you end up with a larger than value, it's going to be outside. If it is less than, it's going to be inside. And if it is equal to, that's when you know it is on the circle. The homework is up on LMS. You guys let me know if you have any questions. Y'all stay cool out there.